Good morning, everyone, and thank you for giving me this opportunity to present our project title Energy Consumption Prediction System using Machine Learning. This project focuses on one of the most pressing challenges in modern infrastructure optimizing energy usage in buildings. As urbanization accelerates and smart buildings become more prevalent, the need to monitor and predict energy consumption efficiency has grown significantly. In most modern commercial and residential buildings, a sustainable portion of total operation cost is directly linked to energy usage, primarily due to systems such as HVAC, lighting, and other automated processes running continuously. The motivation behind this project stems from the increasing globally emphasis on sustainability and reducing carbon footprints. Energy efficiency is not just an economic concern, it is also an environmental imperative. To solve this problem, we developed a machine learning based prediction model that takes into account various environmental and operational parameters to forecast energy consumption. Let me explain how the system works. From a user's perspective, when a user opens this interface, they are presented with a clean and user friendly dashboard where they can input various conditions. There are sliders from continuous features like temperature, humidity, and occupancy levels, and numeric or categorical sections for the others, such as HVAC settings or building area. Once the user chooses or adjusts these parameters to reflect current or hypological conditions, they can click on a button labeled Predict Energy Consumption. At this point, the backend system triggers the machine learning model, which processes the inputs through data preprocessing steps into normalize and align them with a trained model's expectations. To make interpretation easy, the system also includes multiple visual analytic features. One of them is a real-time energy usage trend graph showing how energy changes as individual parameters. When occupancy increases during business hours or when temperature rises in summer months, another visualization shows the feature correlation between two input parameters and energy usage, helping users understand which factors most strongly affect overall consumption. And next, let's talk about model performance evaluation. To ensure that our system is both reliable and practical, we used standard regression evaluation metrics such as R squared score, root mean square error, and mean absolute error. The R squared score is particularly tells how well the model explains in the variance in the target variable. In other words, how accurately it can predict energy consumption compared to real world observations. Our trained model achieved a R-square values close to zero point 0.9, which means it can predict any energy consumption with around 90% accuracy, indicating a strong correlation between the input parameters and the predicted output. The project scope extends beyond just prediction. It opens doors for several real-world applications. One of the most important uses in smart buildings where systems could automatically adjust lighting, air conditioning, or heating operations based on predicted demand. As we conclude, it's important to highlight the broader impact and potential future advancements of this project. While our current implementation uses static datasets and manually input parameters, future improvements can include integration with real time sensors and IoT devices. This would allow the system to adapt dynamically to in conditions making energy management more autonomous. Another enhancement could be automated control feedback where the system does not just predict consumption but also sends adjustment signals to devices. For example, reduce HVAC power when predicted demand surpasses a certain threshold. We can also deploy the entire architecture on cloud platforms such as AWS or Google Cloud to improve scalability, accessibility, and real time collaboration. In addition, applying deep learning models like long short term memory networks could capture temporal patterns more accurately, further improving long term prediction consistency. In conclusion, the energy consumption prediction system using machine learning demonstrates how artificial intelligence can transform traditional energy monitoring into a smart, predictive, and sustainable solution. Our system takes a data driven approach that blends environmental insights with computational intelligence to address a real world problem of energy inefficiency in modern.